All right, so this week we're going to be learning about waves. Don't forget about the red slides. This is when you should take notes. You should have your waves handout. Don't forget to look for the owl and describe them at the end, and give me a 2 to 3 sentence summary of what you learned. Okay, so what exactly is a wave? A wave, I think, is something that you would know it when you see it. We see a water wave in this picture, but there's lots of other different kinds of waves. You can make a wave in a rope. There's sound waves, there's light waves. All of these different things come in the form of waves. So we need to know exactly what a wave is. One of the interesting things that you can see in this picture is the idea of the motion of the wave. We tend to think of like ocean waves and things like that when you're standing on the beach and you see the waves coming towards you. So we think of the wave as sort of moving across the ocean. But interestingly, if you're on a boat, then you don't really move with the wave if you're out in the ocean. If a wave goes by, you just kind of bob up and down. And so we need to think of the motion of the wave, and we need to also think of what is the actual stuff that the wave is made out of. What is it doing? In the case of an ocean wave, the actual water is kind of taking this motion here, this circular motion that you see with this little ball here. That's actually the water particles, the water molecules themselves are just kind of moving around and around like this. So nothing is actually moving in that direction except for the wave. So if the water itself is not moving in that direction, we need to think about what exactly is it that's moving in that direction. And we can say it's the wave, but what is that? Well, okay. A wave is basically a disturbance that travels through space and time accompanied by a transfer of energy. Yeah, that's right, Darth. A disturbance. So, we need to think of this idea as what is moving towards you in the ocean is basically energy. That's what's coming towards you when you're standing on the beach. It's not really water exactly, it's just the energy, the movement of that water. Okay, so there's two types of waves that we need to know about, and this involves this idea of what I talked about a couple slides ago of the idea of which way that energy is moving or which way the wave is moving versus which way is the actual stuff moving. So take a look at this picture here and you see this rope here, and you can imagine this idea that as somebody kind of moves this rope and makes it into this wave, well, the particles, the part of the rope that's right here, never really moves to the other side of the rope down here. The particles, the rope stuff that this rope is made out of, stays right there, and you can imagine that the movement of it is just kind of an up and down motion. So the particle, the stuff, the rope stuff, is actually just moving up and down, whereas the wave seems to kind of go across in this direction, back and forth that way. So this type of wave is called a transverse wave. Now, one thing we need to know here is the idea of perpendicular versus parallel. And so I think the pictures here, picture's worth 1,000 words. I think this describes it pretty well. Perpendicular is like that. Parallel is like that. But hey, you already knew that, right? Okay, so transverse waves, the particles move perpendicular to the wave motion. In other words, if we kind of track the movement of one of these red dots here, the red dot just kind of goes up and down and up and down. But the wave itself, and you can kind of see this part here, the wave itself is actually moving in this direction along this line here. So we have particles moving up and down, and we have the wave moving from left to right, and right there you can see is perpendicular. Okay, the particles are moving perpendicular to the direction that the wave itself is moving. Here's another image for you of a transverse wave. You can see again that the stuff moves up and down, whereas the wave, or what they call the propagation of the wave, you don't need to know that word, but it's a good word. The propagation of the wave, or the movement of the energy of the wave, is moving along this way, perpendicular. All right, so let's label this here. So we have particle direction in this transverse wave is going to be up and down, whereas the wave direction is going to be left and right. Please label those on your notes page. So our other type of wave is called a longitudinal wave, or what is also known as a compression wave. I kind of like calling it a compression wave because I think that it describes what's going on there. You may know what it means to compress something, to squish it. And that's basically what's happening here. If you look right at the end here, when this wave starts, you can see that it's basically getting squished. And then there's a wave of squishedness, I guess you would call it, that's traveling from one end to the other. And so the actual direction, the movement of these particles is back and forth this way. Again, you can see this black highlighted part here moves right and left. And the wave itself, this guy right here, actually also moves right to right and left, actually left to right. So, as we can see, notice the two lines here are parallel to each other. So, with a compression wave or a longitudinal wave, the particles travel parallel to the direction of the wave motion. One thing that we're going to be learning about soon is the idea of sound, and this is basically how sound works. It works by sending waves through usually the air, but it could also be water or a solid object or something like that, like if you knock on a door. But basically the idea here is you're creating compression waves through the air, and that's how we hear sound. We'll talk a lot more about that later. All right, so make sure you guys draw this, and make sure you guys draw it very accurately, okay? Notice that this section, the lines are spread apart, and this section, the lines are very close together. And we're going to label those. So wave motion is that way, and particle motion is also that way. The parts where the waves are close together, or where the particles are close together, is a compression, and the part where they are spread apart is a rarefaction. Please label those in your notes. And again, this is similar to a sound wave and the way a sound wave works. We'll learn more about that later, but for now I would like you to know that sound waves are compression waves. Okay, let's talk about wave properties. Now, properties are things you use to describe about an object. So you could describe the height of yourself, you could describe your age, you could describe the color of your hair or the color of your eyes, and those would all be properties about you. So we want to describe properties of this wave, things that we can measure about it. And the first one I want to talk about is the idea of amplitude. So this is the height from the rest point, or the middle. So it's not all the way from the top to the bottom, it's from the middle to the top. That was a horrible line. Or the middle to the bottom. And obviously, since this line here is in the middle, then measuring from the middle to the top and measuring from the middle to the bottom would give you the same number. So it doesn't matter if you measure from the middle to the top or the middle to the bottom, that is the amplitude. But let's just think of it as like this guy right here. That's the amplitude. From the middle rest position, think of a rope when you're not making a wave in it, when it's just tight and straight. And then that's your rest point, and then your amplitude would be, once you start shaking that rope, how high up and down, how much it goes starting from that resting point. And in this situation, it's important because remember, waves are basically a transfer of energy. So we need to understand the idea of how much energy it's transferring. So the larger the amplitude, the taller this wave is, the more energy it has. And I think you guys can kind of understand that a really big, tall wave in the ocean has more energy, more ability to knock you over and things like that than a really small, short wave. All right, this right here is the crest. That's the top of the wave. And This guy down here, the bottom, is the trough, the bottom of the wave. And one more thing, the wavelength. Now, a lot of people have trouble with this. Don't have trouble with this. This is easy. This is one of those things where scientists finally decided not to use fancy words. They said, okay, when we measure the length of something, the length is like this way. And so if we're going to measure the length of a wave, what should we call it? Well, it makes sense to call it the wavelength. So that's not too hard to remember, so don't forget that one. It's the length of the wave. So really, it's basically from one crest to another crest, or it could be from one trough to another trough. Really, the idea is that it's from one point on the wave, like let's say this point right here, to the exact same point on the next wave. So we got kind of a crest here, and we've gone down a little bit from that crest. And so that when we go to the next crest and go down a little bit from that next crest to get to the same point. And so that distance from there to there is the wavelength. It's the distance from a point on a wave to the same point on the next wave. If that was confusing to you, just think crest to crest. That's the easiest point to choose. So just choose that one. That makes it easier. And in this case, a shorter wavelength equals more energy. This one might not be as obvious as the idea that the larger amplitude means more energy, but we'll kind of do some experiments with this in class. But what you find is that when you put more energy into a rope or something like this, and you can try it out at home if you want to. If you have a rope or a chain or a piece of string or something, you can take that, and you'll find that the more energy you put into it, the faster you wiggle it back and forth, the smaller the distance between the waves gets, the smaller the wavelength is. So you'll get really short waves when you wiggle it really fast. All right. Frequency. This is probably the most difficult one out of the different properties that we're talking about here. So frequency is the number of waves that pass a point in an amount of time. So I want you guys to count along with me. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. So I don't know if you were counting there, but in that 5-second time period, I saw 3 waves pass by that arrow. So that means that you would have 3 waves in 5 seconds. So that's kind of the idea of what frequency is, how fast those waves are moving by a certain point. The faster they're going, the higher the frequency. So the unit that we use to describe that is hertz, abbreviated HZ, and 1 hertz is 1 wave per second. So this would be a little bit more than 1 wave per second because, or sorry, a little bit less than 1 wave per second because we had only 3 waves in 5 seconds. So it would be something like half a hertz or something like that. I want you to take a close look at this and notice that as the wavelength goes down, which is what's happening here, the frequency goes up. And I want you to make sure you label this in your notes with a down arrow and an up arrow. So as wavelength goes down, frequency goes up. I think you can imagine that if these were big waves were going by, that you would be counting more slowly as you count them go by. But if they're really skinny waves, like these ones right here, then you would be counting a lot faster as you go by. And remember, you're watching the waves go by, and to get the frequency, you're just counting the waves go by, and the quicker you're counting, the higher the frequency. All right, well, that's it for what you need to know about waves. We'll do a whole lot of different activities on this and try to get you to understand this a little bit better in class. But basically for right now, what we've talked about is that a wave is a transfer of energy. There are 2 types of waves. There are transverse waves where the particles move perpendicular to the direction of the wave, and we have longitudinal waves in which the particles move parallel to the direction of the waves. We have some wave properties, things we can measure and label on a wave. We have crests, which are the peak, the top of the wave, troughs, which are the bottom of the wave, the amplitude, which is from the resting point to the peak, the crest of the wave. We have the wavelength, which is from crest to crest, and we have the frequency, which is the number of waves that pass by in a second. That's all, and make sure you finish up with your homework. Make sure you get all your notes filled in and give me a nice little summary and tell me where you saw the owl, and I will see you in class.